Hello everyone, in this video we're going to look at the homework 5 and 6. Okay. I think I have to use the calculator. So it's the following a probability model. So probability model, you add all the probability together. If it equals 1, it's a probability model. If it's not a probability. So 0.3 plus 0 plus 0.15 plus 0.3 plus 0.15 plus 0.15 equals 1.05. So it is not 1, so it is not a probability. Alright, so 28 over 100 for this one. Next, the flip result based on the given data. You have 28 tails 100 times. So the probability in a flip a tail is 28 over 100, so it's 0.28. A even number less than 1, so it's just a 2. It's one number, 1 out of 5. The game of roulette will consider 52 slots number from 0 to 50 to play the game. A metal ball is spun around the wheel and is allowed to fall into one of the number slot. So sample space is 0, 0, 0, 1 until 50. Determine the probability that it falls into a slot marked 3. So how many we have is 52, so the 1 out of 52. And interpret this probability, choose the correct answer below. If the wheel is spun 100 times, it's expected about 90 of those times result in slot 3. So if you have 100 times, so it's 100 times 1 divided by 52. So 100 times the probability. If it's 1,000 times, expect 19 of those times. Okay, so it's B. Okay, so the probability that the metal ball lands in an odd slot. So odd numbers, it's 1, 3, 5, 50. You have 25 over 52, and because you have 25 odd numbers, then 25 over 52 simplify. No, we cannot simplify. It's just 25 over 52. So you can finish this one by yourself. It's as similar as the previous one. Okay. Next one is a pretty simple one. In a national survey, a college student will ask, how often do you wear a sweater belt when riding a car driving by someone else? So then you have this one, never, probability. The frequency is 103. So let's see if we can find the probability. You can do it in Excel. Well, let me see if I can do it in StatCrunch. Probability is kind of like a frequency. So let me see if I can do it from this one. Let me just in Excel. If you open the Excel, you're going to see the numbers. Okay, so 103, the total is, let's see, the total summation is 4,526. 4,526. Let's just put it here, equals 103, not 103, just equals this B2 divided by 4,526. That's the total. Okay, so I drag this down. You have all the probability. The probability of this one is 0.023. And this one, just copy that. 667 and copy that. And this is your probability. You just use this number divided by the total. So 4. Always use this number divided by the total. So 7. Okay. And would you consider it's unusual to find a college student who never wears a seat belt when riding a car driving to somewhere else? So unusual to never wear a seat belt. So never, so it's 0.023. It is not unusual because the probability is, okay, it is unusual, yes, because most of the students wear the safety belt. Just the very few, 0.023 probability that they don't wear a seat belt. It is unusual, yes. Less than that, yes. It is unusual. Next question. Given the table 6 possible definition is consistent with the definition of probability model. Common answer needed. So assignments A. So basically test which one give you 1. So A is a probability because you add all together is 1. B, that's right, you got 1. C, check it. 14.2, 14.2, 14.5. Say yes. D, no, you have a negative. You have a negative. E, 3 halves. Okay, is half 1 half? No, E is not because you add E together is not 1. F, 1 half. This is 10, 1 half. E, I think yes. You add everything together is 1. Alright, let me see. This is E add together is 1. Add together it's 1. Okay. Hat, tail, 6 possible. Oh, twice. Okay, that's different. The hat twice. Not all of them. Sorry, my bad. It's just the coin, not for just add to 1. So hat, tail. It's going to be just the A. Wait, the probability of even must be greater than 0, less than 1. Use a given table which lists the 6 possible assignments of the probability for tossing a coin twice to determine which of the assignments of probability are consistent with the definition of probability model. So hat, tail, hat, tail is 1/4 is 1/4 are consistent with the definition of probability model. If you add them together is 1 is a probability. So you add them, but this is a coin. You toss twice, you have hat, tail, hat, tail. It should be A. But if it's a 6 possible assignments, okay, it could be the other one because it does not say it's fair coin. So 6 possible assignments A, B, C, D, E. Okay, so you add B together is 1. Let me just B. C 1/4, 1/7. So it's 2/7, 2/14, plus 2/14, plus 5/14, plus 5/14. So it's 14 out of 14 is 1. Should be right. D is not right because you have a negative probability, which is not right. E 1/6 plus 1/6 plus 1/6 is 3/6. It's 1/2 plus 1/3 is not right. F 1/10 plus 2/10 plus 2/10. So it's 5/10 plus 1/2, which is 1. Yeah, this is right. So F is right. Let me say F 7, 4, 4. 4 plus 10, that's right. Only A, B, you add together is 1. Okay, that's right. A baseball player hits 68 runs in a season, over 68 home runs, 17 went to right field, 25 went to right field, center field, the other one to the center field. Okay, you have all of this. So the probability, what's the probability that a random selected home run was hit to center field was the unusual? Okay, so this is a pretty simple one. Probability that a random selected home run was hit to center field, you just use a center field divided by the total. Okay. Let me see next one. A recent survey was found that median income of family A is that. What's the probability that a random selected family has an income greater than that? Okay, so if it's a median is that, so which means 50% is less than this number, 50% is more than this number. So if it's a probability, it's going to be 0.5. Okay. So you have 4 green, 9 yellow, 2 brown. Find the probability of following event. The probability to get a ball is green or yellow. Green or yellow, so it's 13. Because you have 4 plus 9, it's green or yellow. So divide the total, which is 15. And the probability is not type of A. Not type of A is just B and C. So it's 11 over total is 16. Alright, so this one. Determine the probability that a random selected multiple birth for 15 to 54 years, 30 to 39. So for this one, we can also do, we can use the Excel to do this. Alright, so first of all, I need to find the total. 7402. 7402. So now 30 to 39, so is this two number. Give you 4682. Just add these two. You can select these two. You can see sum of these two, 4682. Just type in those numbers. And what you got is 4682 divided the total is 7402 equals 0.64, 3 decimals, 33. Not that, so 1 minus this number, 367. Because it's this number and the probability not is 1 minus this. Less than 45, so choose everything 7287. You can see the sum here. Sum is selected this before 45, so 7287 divided by total. So 7287 divided by 7402, 98.4. 3 decimals. Less than 20, so it's 91. 91 divided by the total, 7402. 0.122. Oh, at least 20, so I have to 1 minus this number. 9988. Okay. A standard deck of cards contains 52 cards. One card is selected from the deck. Compute the probability randomly select a queen or 4. So a queen or 4. How many queens do we have in a deck? 4 queens and 4 fours. So together it's 8 out of 52. Simplify it. Reduce by 2. Since I have 4 queens, 4 fours, so I have 8 cards, and the total is 52. So 4 queen plus 4 4, so you have 8 over 52 reduced by 4, so it's 2 over 13. Queen or 4 or ace. So you have 4 queens, 4 fours, 4 aces. So it's 12 cars over 52. Reduced by 4, so it's going to be 3 over 13. Jack or diamond. So Jack, we have 4 Jack. Diamond, you have 13 cards. But if there is one contained, you have 4 Jack. Actually, one of the Jack is a diamond Jack, right? So actually have 3 Jack. I mean 4 Jack. You can only use the diamond Jack once. 3 plus 13, because this 13 cards already have a Jack, have a diamond Jack. So it's 3 plus 13, so 16 out of 52. Okay, you have to, if you use 4 plus 13, you have subtracted that diamond Jack, because that Jack has been counted twice. So reduced by 4 is 4 out of 13. Alright, so you have this, click that. A social worker of child advocacy center has this. To the table, it should be easy one. Open in the Excel. The probability one is pretty simple. You just use that number divided by the total normally. What's the probability that one of her clients selected at random is between 6 and 10 years old? Is this unusual? Okay. It's not right. Let me open again. Okay, so it's total 24. We can see the sum of this total is 24. That's the total. Now it selects 6 to 10. 6 to 10 years old is 5 out of 24 the total. Wait. The probability one of our clients select a random between 6 and 10 years old. Between 6 and 10 years old is 5. Okay. So as case note of 24, case and age. Is this unusual? Nearest, okay, I have to use the decimals. 5 over 24 equals. So I have to put this one like this. 208. Okay, is this unusual? Unusual means not often. I think it's not unusual. What's the probability that one of clients more than 5 years old? More than 5 years old is 16. 5 plus 7 plus 4. You choose these 3 numbers is 16. 16 out of 24. 0.667. Okay, so the probability that one of is less than 1 year old, 0.333. Wait, less than 1 year old. Okay, and the 1 year old is 1. Sorry, my bad. Is less than 1 year old is 1 out of 24. Just one number. And I copy that to here, so it's 47. Oh, 3 decimals. 2. Okay, is this unusual? Yes, this is very unusual. Okay. According to the survey, probability that a randomly selected work primarily drives motorcycles, that probability that selected does complete. Okay. So, drives motorcycle, takes public transportation to work. Selected public transport. To add those two, you can add those 2, 0.865 plus 0.043. That's more than 3 decimals. Okay. What's the probability random select primary never drives a motorcycle with that to work? So you just subtract 1. Not negative. So does not drive a motorcycle to work? is 1 minus this number, because this is drives motorcycle to work. So it's 1 minus 0.865, 1635. Okay. And can the probability that a random select work primary walks to work equal to 0.15? Why not? Because you have that is 0.908. You have 0.908. Subtract 1. Your maximum is 0.092. You cannot have a number bigger than this number to walk. So 0.15 plus 0.908, it is bigger than 1. So no, because if you add those probability, it's bigger than 1. Okay, if an active duty military person is selected at random, what's the probability that an individual is an officer? So you just use the officer divide by the total. Okay, active duty military is selected more random. So active duty military, what's the probability that an individual is an officer? So you use the officer divided by the total. Okay. It should be pretty simple one. Determine whether an event E and F are independent or dependent. Justify your answer. A person is going into debt. The same person having a credit card. They are E and F are independent because having a credit card not affect probability of a person going to in debt. I think it's wait. They are independent because going to debt has no impact probably of having a credit card. I would think they are a person going to debt, the some person having a credit card. They are dependent. Okay, the having a credit card can affect probability of a person going to debt. I think they are dependent probably. They are independent. Dependent because going to have no. Okay. Random selected person accidentally killed a spider. Another random selected person swallowing a spider. So they are independent. Because person killing could never occur, so the events are neither independent. Kill a spider, swallow can affect the probability because the people randomly select the events are dependent. E cannot affect F, vice versa, because are random, so the events are independent. Okay. The usually foggy weather in London is May 8th. The number of car accidents in 8. Okay, so they could. The unusual foggy weather in London on May could affect the number of that, so are dependent. Okay. I would think that's the probability of both. Well, math probability should be a simple one. A test determine that is mean negative, compass not. What's the probability of 6 people? Should be fine. The probability that random selected 4-year-old chipmunk will live 5-year-old is 0.5. What is the probability that 2 random selected 4-year-old will live? Oh, this is a binomial distribution. Probably I have to do a little bit on this one. What is the probability that 6 random selected 4 will live on 5 years old? If it's binomial distribution, I have to use the binomial formula. Okay. So the probability that a random selected 4-year-old will live, 1 is like that. Probability 2 selected 4. So have choose 4, choose 2 from. Okay, 1. The probability that what's the probability that 2 random selected will live 5-year-old? Okay, so it's 0.87, 137. Square, so I have 2 of them. 5 decimals. 1, 2, 3, 4, 5. Okay. 2 is just a square this probability. What is probability that 6 randomly selected will be? Okay. So just use that the probability multiply 6 times. 0.87 137 raise up to the 6th power equals 5 decimals to 4. Okay, among 33 to 38 years old, 34 say they have driven a car well under influence of peer pressure. Suppose 33 to 38 are say random. What is probability that at least one has not driven a car well under the influence of peer pressure? At least one means 1 minus at least one. You can use the opposite event. So 34, at least one is none of them. None of that. So suppose 2 as like random. Okay. 34 says the under influence under pressure. So 0.34 under pressure, 0.68. Okay, 0.34 is under pressure. 0.68 no pressure. So at least one has not have a pressure. So this has a pressure. It's binomial distribution. So both says they have no pressure. So it's 0.34 times 0.34. So this means both don't have pressure. And subtract 1, it means it has at least one have pressure. So it's 0.8844. Okay. At least one of the two randomly selected has at least one. So at least one of the two randomly selected, at least one. So none of them. You have to use the opposite event to do this one. At least one of the two select has driven a car under the pressure. At least one. So it's no pressure. 34 says, okay, so you do this. 0.68 multiplied by 0.68. This means both says the end pressure. At least one, so minus 1. 537. Right. Probably at least one of the two randomly selected adults drive a car well under the influence of peer pressure. So one under pressure is 0.34. I have to write it. It's much better. So under pressure. Okay. Both under pressure is 0.34. 0.34 times 0.34. That's both under pressure. So it's a 0.1156. Both under pressure. And one under pressure. To choose one from the two. Alright, so both one under pressure. This is both under pressure, one under pressure, and 0 under pressure. 0 under pressure, so it's going to be times 0.68, 0.4624. And the one, at least one under pressure. It's going to be 1 minus 0.4624 minus 0.1156, 0.422. Okay, this is 1 under pressure. This is 0 under pressure, both under pressure. Probability that at least one of the two random set, okay, so it's at least one. It's going to be this one plus this one. Wait. At least one has not driven a car while under the influence of pressure. At least one under pressure. Wait, is it 1 minus the previous one? 1 minus 0.8844, 0.1156. This is the binomial distribution. I have to write it. If you do this, it's much harder to do this way. If you have to maybe write it, it's much better. 115,644, I think. Okay, I just got this one, the previous one. Okay, so you have the probability that at least one of the two random. Let's do a different one. Okay. So 34 says they have operated heavy under pressure. 34%. Now I have two people. So both will be under pressure. So it's 0.34 times 0.34. That's both will be under pressure. At least one not under pressure, subtract 1. 0.8844. Kidding. Okay, so 0.34 times 0.34. So both have operated under pressure. Let me just do it on paper. 0.34 says have under pressure, and this is under pressure. 0.66 not under pressure. So now the probability at least one has not operated a heavy machine while under pressure under the influence of sugar. Okay, that's sugar. So at least one has not. So if both, at least one, so it's 1 minus probability both under the influence of sugar. So it's 1 minus 0.34 times 3.34. That's right. 0.34 times 0.34 equals minus 1 equals 0.844. Round 4 decimals as needed. 0.8844. I think it's 844. That's not right. It should be 88844. Let me do it again. Sometimes the system is wrong. Let me submit question. Among 38 to 25%, they have operated half machine while under the influence of alcohol. 25%, so 0.25. Suppose 3 to snack run. What's the probability that at least one? Oh, 3. Actually, I have 3 now. This is 3 person. Okay. So 3 person, you have 0.25 times 0.25 times 0.25 equals minus 1. So all 3 are not under influence. So now it's 0.8984. 3 random. That's right. 0.25. I think I'm doing it right. Let me just pause it. Okay, this is 4 decimals. 9844. Okay. The probability that at least one of the 3 randomly selected adults has operated under the influence of the alcohol. So at least one under the influence, which means I have to find out all 3 are not under 3 under the influence. So not under influence is 0.75. All 3 not under influence is cube. So check the 1 equals. So it don't have a negative. Okay. Suppose that a single card is selected from a standard 52 card deck. What is the probability that a card is drawn a spade? Spade is 1/4. You have 4. The probability is, given that card is black, we have 26 black cards. Probability that card is drawn from the side is a spade. So it's 1/2. Okay. So in the original poll, a random sample days, what do you sample size, purchase likelihood, more likely, what's the probability that a random selected 44 given individuals in either or more or less? Okay. So what is probability that a random selected individual 45 to 54 given individual is neither more or less likely to buy a product emphasized made in our country? More, given this, given the individual is more, neither more or less. So neither more or less is 162. So at 161, neither more or less is 161. So it's 161. That's this number divided by the total. Okay. Divided by total. Divided by the total given is this, neither or less likely. So the total of this is 7. You look at neither or more or less. This is the given is the denominator. So given is the condition. The total of the neither more or less likely, the total is 776. So it's 167 divided by 776. You have to use the calculator. Okay, so 161 divided by 776. 3 decimals. Okay, the rest of them should be the same, very similar. Determine the probability that at least 2 people in a room of 9 share the same birthday, ignoring the leap years of assuming that each birthday is equal likely by answering the following questions. Compute the probability that 9 people have different birthdays. Okay, complement of 9 have different birthdays. At least 2 share the same birthday. Use this information to compute the probability at least 2 people with the same birthday. So, the probability that at least 2 people in the room share the same birthday. Compute the probability that 9 people have different birthdays. 9 people have different birthdays. So 365. Each one of them is 1/365. So the next one, you have 355/365. You have that options. Compute the probability that 9 people have different birthdays. Let me share the same birthday. Let me check it very quick. Okay, so the first one, you have the first person have 365 options. 365. Once that data is given, then it's 364. The next person, 363, 362. Basically, you have to do this 361. So next is 360, and next you have 359 options. 1, 2, 3, 4, 5, 6, 7, 8. So 358, 357. The total bottom is 365 always. Okay. And you multiply them divided by each other. So this equals this divided by the next one. So that's the first one, you can choose any day. The next one, you only have 364 days can choose. And then this is the probability that you can have. The next person, you can only have 364 days because the first person have to choose the first day, choose one day. So next person only have 364 options. The next person you only have 363 options because those 2 days we can't take. Okay, so you have 9, these are the probabilities. You multiply all the probability together, it's going to be a final probability. So equals multiply this, multiply this, multiply this, multiply this, multiply this. So equals, this is your final answer, 954 decimals. Okay. And then at least 2 people share the same birthday. At least 2 share the same birthday, which means that opposite even of this one. So 1 minus 0.954 okay. Verify this is a discrete probability. This is a discrete probability because the sum of the probability is 1, and if you add those together, if it's 1, yes, it is a probability. Okay, let's check it, see if it's 1. So you add all the probability together, it's 1, yes, and the sum is 1, and each probability is between 0 and 1, inclusive 0 and 1, so it's a probability. So then you graph it. Graph this one. Let me see. You can insert a page, this one. Okay, you can see it's down, and then it's going to be just like A. The mean value, the mean is, okay, the mean value is, how you do the mean value? The mean is x times px equals x times px. Okay, the x times px, next one is x times ps. You just drag this down, x times px, x times px. So 0 times 0.165 plus 1 times this probability plus 2 times this probability plus 3 times this probability plus 4 times this probability. So 4 times this, you have this number. You add this, all of this together is 2.48. 2.48, the sum. You look at the sum here in the bottom, 2.48. Round to 1 decimal, so it's 2.5. Okay, so just multiply them. Multiply 1 times this, 2 times this, 3 times this, 4 times this, you have this number. You only have to do the first one, then you can just drag it down, you have all the rest, and add them together is going to be a mean value. Which of the following interpretation of mean is correct? Okay, 2.5, that means 2.5. 2.5 is right here, 1, 0, 1, 2, 3, 4. The mean observational approach mean of that. The observed value of will be less than. Okay, you can figure out the ABC yourself later. Okay, the expected value. Suppose a life insurance sells 160,000 1-year term life insurance policy to a 25-year-old female for 330. The probability that a female survives the year is 0.999489. Compute the interpreted expected value of this policy to the insurance company. So you have 0.999489. Okay, and what's the probability that this female is dying is 1 minus 0.09999489. That's the probability. Once this happened, you compensate 160,000. Okay, it's 81.76 once that happened. Okay, but now you claim $330 a year. So expected value, so it's going to be 330 minus 81.76. So the insurance company actually have expected value of this. Okay. So which of the interpretation expect is correct? The insurance company expect to make an average of that on every for a year. That's right. Make average of this. This is the insurance company's profit. Okay, make $248 a year. Okay, so this should be the same as the previous one. You use that probability times of the investment account believes that if the company remains strong, the investment result in a 30,000. So 30,000. If the company grow moderate and a 10,000. However, if the economy goes into recession, the invest result a loss of negative 30,000. Your contract economy believes that 30%, so it's 0.3, and 60%, and 10%. So what is expected profit? You multiply this equals 30,000, this one, multiply this one equals, then dragging down, and you add that together is $12,000. Okay. So this is how you do. You find that 30,000 multiplied by 0.3, 10,000 multiplied by 0.6, negative 30,000 multiplied by 0.01. You get all of this number. They add this together, give you a mean value. Okay. So this is the same. If the grand prize is 160,000, enterprise cash ticket cost is 1. What's the expected profit? It's the same as the insurance company one. Okay. So now, and equals this price multiplied by the probability of this one. Wait, equals multiplied by this equals. That's almost 0. Add together. Equals. Let me say again. Equals this number multiplied by this number equals, and then dragging down. Okay, that's your total. The sum, you can do equal sum of all of the profit, the return. Okay, if it's $1, you have return is 0.2388. What's the profit from one ticket? The profit, what is your expected profit? There's no profit, so it's just 0.238819 subtract $1. This is the profit. Profit, they round to nearest the cents, so negative. Oh, I think the profit is just use this. Actually, it doesn't count that you spend $1. 24. Okay, so continue. And average, what's the correct interpretation? You will win. Point that, no, you will win. On average, you will win per. Okay, so this is the right answer. You will win that. It doesn't mean that's your profit because you spend $1 to buy the ticket. Okay. Expected profit from one ticket actually is negative 0.676. You lose the money to buy. If you spend $1, you only got 24 cents as the reward. To the nearest million, how much should the grant price so that it can expect it? How much should a grant price so that it can expect a profit? Assuming nobody else wins, so that you do not have to share the grant price. Okay, so this one, you got all of this, it's 0.153 because the probability is this. So basically it's 1 over this equals So how many million? Okay, divided by this is 1 million is like that. There's 186 187 million. How much should the grant price show that you can expect a profit? I will share the grant price. So that's probably 1 divided by this number. See. $187 million. Assume nobody else wins so that you do not have to share the grant price. The nearest how much grant? One ticket, yes. Okay, I should use 0.76 divided by this number because you win the rest as well. 142. 142 million. No? Okay. Because to nearest the million, how much should the grant price so that you can expect profit? Assume nobody else wins, so that you do not have to share the grant price. You don't share this one. Okay, so basically this is your return. Nobody shared the price. You got 15 cents. So 0.153218964. So what you need to do, 1 minus whatever you got from here. 0.0028, add everything together here. You got 0.1532. This is the return besides the grant price. Okay, you have some return here. So add all of this together, subtract that $1 and divide it by this probability. That's going to give you 152 million. 3, 4, 5, 6. Okay, 158. So 158 or 159, either one. I think at least 159 million. If you round it up, it's 158. 159. Oh, so the correct answer is 159 million. I forgot to put the zeros, so it's 159 million. Okay, and then continue. Does this size of grant affect the chance of winning? No, because the probability, the chance of winning determines the probability of the lottery and other payouts. Okay, the probability is always the same. That's how you do this one.